Hi everyone, I'm Sandhya, Department of Mathematics. Today we are going to see about the special types of a graph. In the special types of a graph, first we are going to see about the regular graph. What is a regular graph? Every vertex having the same degree, that graph is called the regular graph. We are going to see about the some example of a regular graph. In the see the first three graphs having the same degree, that is every vertex having the that is the degree of 2. So it is called the two regular graph. In this third and that is the fourth and fifth one, every vertex having the degree of 3. It is the three regular graph. Okay. Next, we are going to see about the complete graph. In a graph, if there exists an edge between the every pair of vertices, then such a graph is called the complete graph. Okay, so here every complete graph is a regular graph. So every complete graph is a regular graph. Okay, every complete graph with a vertices is a n minus 1 regular graph. Here the complete graph n vertices is denoted by kn. So every single vertices is also a complete graph. Okay, here we are going to see about some example of a complete graph. The first one is k1. Here there are two vertices, so here we denoted by k2, and similarly third one is k3 and the fourth one is k4. Okay, next we are going to see about the bipartite graph. In this bipartite graph, a vertex set V of G can be partitioned into two disjoint non-empty set, that is V1 and V2. Here we are taking V1 union V2, that is V of G. Such every edges in E of G has one end vertex in Vi and consider at in the vertex in V2. Here we are going to see about one example. In this example, there are 6 vertices are there. We are going to take V1 and V2. In this V1, here we are in this V1 we are selecting V1, V3 and V5. Here also that is V2 is V2, V4 and V6. So it is a bipartite graph. Okay, next we are going to see next example is a bipartite graph. Here we are going to in this triangle, so it cannot be disjoint non-empty subsets since any two vertices are the adjacent. Hence, the K2 is not a bipartite. Okay, here we are going to see about the third example. In this third example, it is a bipartite or not. Here we are going to see we cannot that is partition V into a disjoint non-empty subset because the V2 is adjacent in every other vertex and V6 also adjacent to every other vertex. Hence, G is not bipartite. Okay. So, next we are going to see about the complete bipartite graph. So, first in this bipartite graph, we are partition into two, we get the original graph. Okay, next we are going to see about the complete bipartite graph. In this complete bipartite graph, a bipartite graph of G with bipartites V1 and V2 is called the complete bipartite of a graph of every vertices in V1 is adjacent to every vertex in V2. Clearly, every vertex in V2 is adjacent to every vertex in V2. Okay, so here we are going to see a complete graph with M and N vertices. In the bipartite is denoted by Km. So here it is denoted by K 3. Here also the second one is represented by K 3, 3. Next we are going to see about the subgraph. In the subgraph, we denoted by h of v comma vertices is called the subgraph. Here the graph is nothing but the combination of vertices and edges. Okay, here v dash containing v and okay. So in other words, the graph H is said to be a subgraph of G if all the vertices and all the edges of H, one is G, and another one is adjacent preserved in H exactly as in the G. Note, each graph has an even subgraph is a simple vertex in a graph. G is a subgraph of G. So here the same vertices also having. Next, a single edges together with the end vertex is called the subgraph of G, and a subgroup of a subgraph of G is also a subgroup of G. Here also we see some example. So first one is a graph. In this graph we have to form the subgraph of H1 and H2. Here we are going to see the first one is subgraph, but is in the not second one is not a subgraph. Here see V3 is connection not connected by, that is here the V4 is not connected by V1 and V4 in this first graph, so it is not a subgraph of G. Okay. Next we are going to see some problems. Okay, in this problem determine with the following graphs are bipartite and with or not. Here we are going to see the first one. In this first one, D, E, F are not connected by the edges. They may be considered the subset of V, that is V equal to D, E, F, and V2 is A, B, C. Okay, so in this the vertices V is connected by the edge, the vertices of V2, but the vertices A, B, C of V2 are the edges of A, B, and B, C. Hence the graph G1 is not a bipartite graph. Okay, thank you.